Hello, my dear students. This is Shad Al-Qassas, the physics teacher, Sharjah American International School. And today we're going to solve some problems related to identifying or calculating the net force. Calculating the net force is one of the important lessons and one of the important skills, especially if you are in grade 10 and 11. This session is due to some requests of my grade 10 students. So please watch this video on our YouTube channel, or also you can go to my blog, which is sites.google.com/site/profshadi, or just type Prof Shadi without spaces on google.com. So today we are going to explain some of the ideas related to calculating the net forces, and we are going to use the iPad for that. We are going now to link the iPad to the computer here using the one of the very important softwares, which is the AirPlay. AirPlay basically is a technology that you can link your laptop with your iPad. So now I'm going to go to my iPad and let's start the session. Due to Isaac Newton, he said that in his first law, he said that an object at rest remains at rest, object in motion remains in motion, unless unbalanced forces acting on the object. So if the object is at rest, it will keep resting. If the object is in motion, it will keep in motion, unless unbalanced force acts on the object. So the object can be balanced or in equilibrium in two cases. If the object is at rest, or if the object is moving with constant velocity. Those are the two cases where you don't have any net force, so the sum of the forces will be equal to 0, and also the acceleration will be equal to 0. We mentioned before that the forces and accelerations are just like twins. If you have sum of forces, you will be having acceleration. If you don't have any forces or a net force, you're not going to have any acceleration. And this is due to Newton's second law. So in order to prove that the object is in equilibrium or not in equilibrium, you need to calculate the net force. And in order to calculate the net force, basically I summarized most of the cases or the situations that you might face in your book or in the exams or quizzes. And you have three cases, and those cases are a horizontal object pulled by horizontal forces. So you have the downward force, which is the Fg. You have upward force, which is the normal force, and you have the applied force here, which is F applied, and you have the friction force, which is F friction. The second case, you may have also a horizontal object, but pulled by an inclined force. So again, the famous forces are Fg, and you have Fn. You have inclined force here, and F friction is parallel to the surface itself. So F applied here is somehow inclined at a certain theta, which is an angle. Suppose that it is at 30 degrees from the horizontal. This is the second case. The third case is an inclined object. So as if an object is sliding on a table. So again, the famous forces are Fg, which is downward, Fn, perpendicular to the surface, F sliding, which is this direction, and F friction. In order to make your x-axis and y-axis, you just have to extend the Fn a little bit here. So by extending this line, you'll be having x-axis and y-axis, and the only force outside of this or out of these axes, you'll find it's Fg. Fg is the only force that is not lying on x or y-axis. So let's start with the first case. If you have an object, suppose that you have a car, a horizontal car. Let's change the color. It's not that good, so let's choose the white. Let's try the white. Suppose that you have a car that moves horizontally and it has Fg downward, Fn upward, and the applied force is here, F applied, and you have F friction here. Let's have some numbers. For example, if this is 70 newtons, and this is 30 newtons, and this is 100 newtons, and this is 100 newtons. As you can see, the object here has 4 forces in 2 axes. You have right and left forces, and you have up and down forces. So you can directly go to the sum of forces, so you can get sum of Fx, which is equal to right minus left, or 70 minus 30, 70 minus 30. And you can go to sum of Fy, which is 100 minus 100. You'll find out that 100 will cancel 100 because it is the same force. And 70 minus 30, which is 40 newtons to the east. Don't forget the direction. It's a vector quantity. And to the east, because 70 is more than the 30, so the object is going to move towards the bigger force. So if you wanted to draw the final object or the final diagram, you'll find out that the object looks like that, pulled with a net force of 14 newtons to the east. And this is the final answer. And for sure, if you are asking yourself now, is this object balanced or not? For sure, it's not balanced because it has a net force. Isaac Newton said, if the object has a net force, so it is not balanced, or it's not in equilibrium. It's not going to keep moving. It's not going to keep to stay at rest. It's going to accelerate or decelerate. So as you can see, the object here is having a net force. This means that it is not going to be in equilibrium. The same case but different situation. It's very important to consider that what if the 100 or the Fn is not going to be equal to Fg. Suppose that we have such situation, such as this object. A car or an object has a downward force of 50 newtons, an upward force of, for example, 100 newtons, east force with 40 newtons, west force with 20 newtons, for example. Here, if you are going to have the sum of Fx and sum of Fy, so let's calculate them together. Sum of Fx is equal to right minus left. Basically, we know that you are adding, but because of the 20 is on the west side, so it's a negative force. So we say that 40 minus 20. So 40 minus 20, which is equal to 20 newtons to the east, and sum of Fy is equal to 100 minus 50, which is equal to 50 newtons to the south, to the north, upward. So those are your forces. One of them is to the east, one of them is to the north. And as you can see, we have 2 forces. How we're going to deal with the 2 forces? So let's suppose that the final figure will be here. It has a 20 to the east and 50 to the north. This is your final figure. As you can see, it's not one force, there are two forces. I need to simplify the problem more. So we are going to use Pythagorean theorem in order to find the net force. As you can see, the object here is pulled by two forces, and if you pull an object to the east and to the north, the object is going to move with a net force to this direction, right? If you are pulling to the right and upward, or if you are pulling an object to the east and to the north, the object is going to move to the northeast, right? Try to imagine that. Try to imagine that it has some weeds here, or you are pulling here and there. So the object is going to be moving in a net force to this direction. How can we calculate this force and the direction of this force? This is our question. So we are going to use Pythagorean theorem. You cannot add them directly because the forces are added tail to tail, and you cannot add vectors tail to tail. So I need to change their directions. So the 20 is here, and I'm going to move this force to this direction here. But don't flip it, just move it parallel. So this is also 50 newtons. And as you can see, we didn't change anything. It is just the 20 is to the east and the 50 is to the north. And this is your resultant force, which is this one. This is the R. So you need to find the R, and you need to find the theta, which is this angle. In order to do that, you need to use Pythagorean theorem and the functions. So let's calculate the forces here. The R is equal to the square root of 20 newtons plus 50 newtons. Find your answer in newtons. This is the net force, the final net force. The theta is equal to tan inverse, which is tan minus 1. It's a crippled n, as usual. Here, tan minus 1, opposite over adjacent, and the opposite to the angle is the 50. So 50 divided by 20. In your calculator, find the theta in degrees. Now I found the magnitude and the direction. This is if you have a horizontal object pulled by two forces. The net forces are two forces and perpendicular forces. If it's one force, you don't have any problem like our first example, but here you have two forces, so you need to use Pythagorean theorem. Let's talk about case 2. And case 2 basically is related also. It would be an object that is horizontal. So I have an object here, like a car, for example, or a box or whatsoever. But this object is pulled by an inclined force. Let's draw the famous forces, Fg, Fn, and the inclined force is here. This is F applied, and F applied here is inclined. It has an angle between the horizontal and the force itself, so this is F applied. And the friction force is here, parallel to the surface. As you can see, the annoying force is the FB. It's very annoying because it's not lying on x-axis or y-axis, so I need to somehow get rid of it, but I cannot cancel it. So let's have this real-life example. If you have 1,000 dirhams and you need to go and buy something, first of all, you need to get some change. the change for the 1,000 dirhams, it could be 400 and 600 because it's a very big value. So you're going to divide this into 400 and 600. And this is what you are going to do with the force F applied. We're going to get it into change, but we're not calling it change in science. We call it the components. You need to get the two components of the F applied. So I need to get the X component of F applied, and I need to get the Y component for the F applied. Let's have an example in order to show you how we can do that. Suppose that I have an object here. It has 100 newtons as a weight. We have here 75 newtons. You have here friction force, suppose that it's 10 newtons. And I have a force here inclined, which is 50 newtons at an angle of 30, for example. The only problem is this 50, so I need to get rid of this 50. The easy way, I taught you in the class, you can use this secret, which is move this force 2 times, one of them towards the x-axis and the other one towards the y-axis. If you are moving it towards the x-axis downward, you'll find out that the line is closing on the angle, closing on this 30. So closing means cosine, so this will be 50 cosine 30. And directly, this one will be 50 sine 30. So now I can get rid of this force. So your problem will be as if you have those forces only. You have 50 cosine 30 because you close on the angle. You are making the angle basically somehow less than the value by closing on it. This is the easier way. You can do it using Pythagorean theorem by making a right triangle here and telling that this is the adjacent, this is the opposite, find x and y, and you will find the same values. But this is an easy way that you can do it right away. So put your pen on the inclined line and then move it once towards the x-axis and once towards the y-axis. If you are closing on the angle, if the angle is between the force and the axis, it's cosine. If you are going away from the angle, it is sine. So this is 50 cosine 30. This is 10 newtons, which is the friction. Don't forget the 100, which is the weight. And don't forget that you have 75 newtons already here upward. And you have another force. This is a common mistake. Please don't forget that after making the components, after getting the components of this inclined force, you have two forces now, which is one of them is the Fn, which was already there, and the other one, which is the 50 sine 30. They are both at the same direction, so you need to add them. After you add them, we can get the sum. So right minus left, total up minus down, and then you can get the F net, sum of Fx, sum of Fy as usual. Calculate 50 cosine 30 minus 10, this is the Fx, and calculate the 75 plus 50 sine 30, I believe that it will be 100. So this one will be cancelled with this one. 100 minus 100 is 0. Make your calculations. And you will find that the final object is moving with one net force. You may have also two forces perpendicular, and then as the previous example, you can follow the same procedure. So I hope that this is clear. The third case, if the object is sliding. So suppose that I have someone here, not good in drawing, so he has very long anyway, and he has a table like that, and the object is going to slide here. So the angle here, suppose that it is at 30 degrees from the horizontal. Let's draw for the famous forces. FG is always downward. Fn perpendicular to the surface or normal to the surface. It's going to slide here, and you have the friction force here. So this is Fn, this is Fg, this is F sliding, and this is friction force. In this case, I don't have an obvious X and Y, so I need to make my own X and Y. How to make the easiest X and Y? As you can see, the Fn and the sliding force and the friction force are perpendicular already. So you just can extend the Y, which is coming from the Fn. You can just extend it a little bit here. Let's make more accurate line. You can just extend this line. So now you have x-axis and y-axis, and you'll find out that the weird force is the Fg. The Fg is not lying on x-axis or y-axis. So to make it more clear for you, now you have x-axis and y-axis, but it is somehow inclined a little bit, like that, and like that. Fn, F sliding, and F friction. The only force that is not on x-axis and y-axis is the Fg. Fg, as you can see, it is an alien force here. So I need again to get the components. I need to get the change of the 1,000 dirhams. I need to get the two components. But the problem is, what is the problem? Can you think a little bit? I have a problem here, which is I don't have exactly. I don't have an angle. So how can I figure out the angle, which is cosine FG cosine what and FG sine what? Where is the angle? So this will give you a clue. The inclination angle is 30. By using some of your skills in math, you'll find out that this 30 is a part of a right triangle here. If this is a right triangle, so if this is 30, this will be 60. So this will be 30, right? Because those are perpendicular already. So this is 60 and this is 30. So directly you can say that the 30 is equal to the far angle. Okay? So let's draw the shape again. If you have an object that is being sliding here, and I have Fn, I have F sliding, I have F friction, and I have an alien force Fg because it's always downward, so it will be alien force here, Fg. Extend the Fn a little bit to make your axis. You can make it a dotted line a little bit. F sliding, Fn, Fg, Fn, and F friction. So the inclination angle is 30. So not the near one, it is the far one. This is the 30 degrees. And follow your secret again. If I wanted Fg component or the change of the 1,000 dirhams, so here I'm going to move it here. Am I closing on the angle or away from the 30? I'm closing on the 30 or away from the 30? What do you think? Exactly, excellent. I am closing on the 30. So it is Fg, cosine or sine? Fg, cosine 30. Very good. And the other side will be Fg, exactly, sine 30, which is sine 30. And now simply I can get rid of this alien force. I don't need it anymore. This force is not there. Thank you very much for the Fg. Okay, I don't need it anymore. So my figure now has 4 forces in each side. And by the way, um, F slide here in this case is Fg sine theta. It is the same force because I'm not going to give it to you in the exam or in the test. It's unknown. Even in the book, you will not find the F slide. So you have to get it yourself, which is Fg sine theta. So Fg sine theta is F sliding. You have F friction given. You have the normal force, and you have Fg cosine theta. Again, you can get the sum of Fx, which is equal to F slide minus F friction, and then you can get Fy, which is also Fn minus Fg sine theta. In most of the cases, this one will be equal to this one, so they will cancel each other. You will be having one force here, which is the net sliding force. So now let's summarize that we have what we have taken: three problems, three main types of cases. You may have an object pulled by horizontal forces. Everything is in front of you. Sum of Fx, sum of Fy, I have no problem. You may have an object, horizontal also, but pulled by an inclined force at an angle from the horizontal, theta. You have your famous forces, oh, I don't like blue. Okay, so you have your famous forces, Fg, Fn, F friction, and in order to get rid of this annoying force, I need to get the two components, right? So I have to get the F applied cosine theta because I am closing on the theta, and then F applied sine theta. Here, don't forget that you have two forces, you have to add them together and then subtract them from the Fg. Now you have right force and left force, also you can subtract them. And the final case is when you have a sliding object like that at an angle theta. You have an object. Also you have some famous forces, Fn, F sliding, F friction, and unfortunately the weird force is Fg. So we need to destroy it. We need to get rid of it by getting its two components. Extend the Fn a little bit in order to have your axis. And don't forget that the theta here is the near one or the far one? Huh? Exactly, the far one, this one. So here the Fg will be cosine Fg sine. These are the three basic cases of the calculating the net force. I hope that you enjoyed the lesson for today. Please, your comments are really valuable to me. Leave your comments. If you have any suggestion or any question, I would appreciate to post them on our YouTube channel or on our website. Thank you very much, and I really hope that you enjoyed this session. Goodbye.